Okay, so we're going to just talk about this article for a little bit, see if it has anything interesting. It looked potentially interesting. We don't actually know. It might be terrible. This is on the Golem Cloud blog. This is the actual article. I was in the wrong place. It was on the Golem Cloud blog. We'll see. We'll see how this goes. I don't. Uh, is there like a nice? Is there like a? Can you just give me like a nice way to view this? No, you're using too much of my screen up. Okay, whatever. It's fine. So what is Golem? That's probably somewhat useful to understand what the heck they're talking about. I've never heard about it before. I just saw this on Twitter. It seemed potentially interesting, and it's about Rust. Apparently, they think they've made a really great service. Golem Cloud. Okay, so let's just read this real quick. Golem is a cloud platform for deploying Invincible serverless workers using the WebAssembly component model. Golem executes workers durably and indefinitely, which means they can be stateful and long-lived. Golem is available as both open source software that you can deploy in your own infrastructure, as well as through Golem Cloud, a hosted solution that is fully managed and requires no infrastructure setup or maintenance. Okay, so let's just look at why Golem real quick. Golem is an evolution of serverless computing that allows workers to be long-lived and stateful through a new paradigm called durable computing. New paradigm, definitely not marketing. Workers deployed into Golem can survive hardware failures. This is how we can kind of know, like, is this actually a new paradigm? Now, maybe they are being very innovation, but yeah, like, yeah. Okay. I mean, softwarecolony.com, durable computing, a game changer for. Okay, John DeGel's also talking about durable computing. I know he's a little controversial, but that's fine. He doesn't make him wrong all the time, right? And okay, so durable computing does seem like it's possibly a real thing. It's possibly a real thing. Maybe we need to read more about that another time. Okay, workers deployed onto Golem can survive hardware failures, upgrades, and updates, offering a reliable foundation for building distributed, stateful applications. Golem does not let you build anything you couldn't build before. Golem does not let. Okay, right? With great expertise and enough time and resources. However, Golem does radically simplify the way you build many classes of cloud applications. Golem shares many of the benefits of serverless computing, including faster development, lower maintenance overhead, and no need for ops. However, there are additional benefits that are unique to Golem, including durable state. Golem lets you store session information, shopping carts, sensor data, user events, and much more in memory because all workers' state is durable. This not only lets you reduce your dependency on databases and dramatically simplify application code, but can also improve performance. Indefinite life. Workers deployed to Golem can run indefinitely, though the node they are executing on might go down. The workers will be transferred to another node and resume execution where they left off. Durable computation can radically simplify orchestration processes and eliminate the need for event sourcing. Interesting. Distributed computing. Workers deployed to Golem can call other workers, which makes them equivalent in expressive power to distributed persistent actors. Actors mentioned, let's go. As such, workers deployed to Golem can solve virtually any problem in distributed computing using techniques pioneered by actor frameworks such as akka or Dapper. All right, cool. So it seems like what they kind of did, maybe there's some other pieces to it too, but they've taken like the actor model and abstracted it out into like an actual infrastructure model. Not that no one's ever tried to do that before, but maybe because they actually mentioned the actor model, like they actually know something about it, where it sometimes feels like everybody else in distributed computing that's doing Kates and all these other things, like they've literally never even heard of Erlang. Like you say Erlang and they're like, what's that? And that's how it feels, at least. You know, maybe not in the academic world, but at least in industry, it feels like you guys have no idea what you're even trying to do. Okay. Examples. We could go through one example. Where did the normies hurt you? Yeah, is it am I a little too strong? Am I too strong against the normies here? Is that the problem? Hey DP 3754, thanks for the follow. Examples. In the following examples, you will learn how several different types of applications could be written for Golem and how this would simplify architecture. Okay, so there's order processing and session management. No, but it was very funny. Okay, good. Order processing. In an online storefront, we may have to take many steps during end-to-end processing of an order. Okay, you can read these. No, okay, I'll read them. Check and reserve sufficient inventory, validate details of the order, such as shipping address, validate payment method details, charge the user's credit card or debit their bank account, retry or abort on an failed charge. Boom. Where's your English here? Just kidding, I'm so bad at English now. As appropriate, or continue on success. Record the successful change in a database, dispatch the order to fulfillment, send the customer an email with their order details. Send the user updates as the state of the order is updated by fulfillment. Handle unexpected errors during fulfillment or the user's cancellation of the order before dispatch, if supported. The major part of this process can take several seconds to several minutes, while the entire process could take days or even weeks. In a perfect world, we could write a simple program that performs all these steps more or less in order in a handful of functions that call out to other web servers. However, if we were to push this naive approach into production, we would run into numerous issues. Due to hardware failures, updates, and upgrades, our program could be interrupted before it finishes, leaving all systems in an inconsistent state. The user might be surprised to see they were charged for the items they ordered without hope of them ever arriving, for example. In order to compensate for these failure scenarios, we would traditionally switch to an event sourcing approach. Because events are stored persistently in a durable message queue like Apache Kafka or Apache Pulsar, we now have a reliable means to detect which steps have been performed and which have not. And we can write processes that recover partially completed orders and resume at the point where they left off. Sure. While industry proven and reliable, this approach ends up significantly increasing our development and maintenance costs and turns what could be a simple and short program into many disparate services, all introducing additional overhead and points of failure. With Golem, the entire order processing process can be written and deployed as a simple serverless worker. The worker will run invincibly with durable state, allowing us to focus on business logic and disregard the complexities of reliable distributed stateful computation in the cloud. Okay, so I'm guessing how this works. Session management, I think it's pretty obvious to anybody who's like built a backend service, right? I'm guessing how this works is similarly to like, so you have your process, and then we're clearly persisting that state somewhere else durably, like it's like an actual persisted state of some sort. Maybe that's like SQLite or something like that. Maybe a distributed SQLite. I don't know. And that way, if something happens to that worker, another worker can pick up where it left off, or once the worker restarts, it can like pick up from there. It's kind of an interesting idea. I mean, it's interesting. You know, like I guess their whole thing is that it's simpler. It's simpler than doing the whole durable queues. I could see that. Okay, this is just a little getting started. I was kind of wanting to see like what an example might look like. So it basically seems like you're just creating like a WASM target, and that's what you're running, and that's their whole like workers thing. Every worker has a unique ID. The WebAssembly component model, your Golem applications are not just an executable, rather they may export functions that can be called from the outside. Exported functions allow your workers to be given instructions or queried for their state. Here we invoke the function initialize cart on the worker with a single string parameter. Okay. All right. Interesting. Ooh, Jason mentioned, let's not go. Let's not go. Okay, I think that's kind of interesting. Okay. Writing templates, tier 1 languages. Let's look at Rust real quick. This is kind of what I wanted to see, is like, what does your actual application look like? Modify the interface definition for the template in wit/world.wit. Never seen .wit as a file type. Interesting. It seems like you're using this to specify your API schema, which again can actually be functions and everything. I don't know if wet is like common in WebAssembly. I've never done any WebAssembly stuff, so I don't really know. In the Rust source code, you generate and import the exported symbols as mod bindings. Sure. Okay. The function exported in the world in this file will be exposed by Golem. In the Rust source code, you generate and import the exported symbols as mod bindings. Use bindings exports my template API, and then implement the guest trait from the interface definition. Okay, I get it. So basically you're defining this, and then you kind of have like a trait that I'm guessing they're generating from there for you, and then you like implement it. Okay, I guess that makes sense. Let's see how you do state. The worker state is persisted by Golem, so all you have to do for state handling is to store data in a global mutable variable. Interesting. Okay. Yeah, I mean, it's kind of cool in the idea. I mean, the problem with this, of course, is like extreme vendor lock-in, you could say. They say you can run it on your own infrastructure, so I guess that'd be like the response to that, is like that would be the way that it's not vendor lock-in. But it is like they handle everything for you. I mean, it is like the whole serverless fantasy, right? You're just writing the code that describes your service worker, implements the like actual logic, like the business logic, and then they kind of handle everything else for you. Yeah, interesting. Okay. Had no idea. I think that's cool. Let's see. Golem's Rust transaction API. Now that I've read all of that, do we want to read this article? That's a good question. My scroll down is slow again. This happens every once in a while. This is literally me scrolling down as fast as I can. Isn't this really good? Isn't that good? Okay. I just have to use number scrolling? No, arrow scrolling. Okay. Okay. Sure. I think this could be interesting. It will probably go over some details about Rust that we could talk about, and then kind of like tie in the idea of the way that Golem's doing this with the way that Rust works. And maybe we'll learn something that's applicable to something besides this. You know, we'll see. So smooth. That smooth scroll. Golem's Rust transaction API. Posted on April 13th, 2024. That's today, guys. That's literally today. I'm so current. It's unbelievable how current this stream is. Okay. Introduction. A few weeks ago, cutting edge news. A few weeks ago, we've added a new set of host functions to Golem, which allow programs running on this platform to control some of the persistency and transactional behavior of the executor. executor, executor, probably executor, executor. I guess you can say it both ways. You can learn about these low-level functions on the corresponding Learn page. These exported functions allow a lot of control, but they are very low level and definitely not pleasant to use directly. To make them nicer, we can write language-specific wrapper libraries on top of them, providing a first-class experience for the supported programming languages. Okay. The first such wrapper library is Golem Rust, and this post explains some of the Rust-specific technical details of how this library works. Regional changes. The easy part is providing higher level support for temporarily changing the executor's behavior. I guess I'm saying executor. The common property of these host functions is that they come in pairs. The mark begin operation, mark end operation pair defines a region that is treated as an atomic operation. We can get the current retry policy and change it to something else with the get retry policy and set retry policy functions. We can control persistency. This is basically like prose documentation. It's killing me. We can control persistency with get up log persistence level and set up log persistence level. And we can change whether the executor assumes that external calls are idempotent using the get idempotence mode and set idempotence mode pair. For all these, a simple way to make them more safe and more idiomatic is to connect the lifetime of the temporarily changed behavior to the lifetime of a Rust variable. Sure. We'll just keep going with it. For example, in the following snippet, the whole function will be treated as an atomic region, but as soon as the function returns, the region ends. Sure. So you have an atomic operation, you do something, you're saying Golem Rust, mark atomic operation. Sure. Implementing these wrappers is quite simple. First, we need to define data type, which the wrapper will return. Let's call it atomic operation guard. Okay. We store the return value of Golem's mark begin operation in it, as we have to pass the value to the mark end operation when we want to close the atomic region. We want to close the atomic region when this value is dropped, so we can call Golem's mark end operation in an explicitly implemented drop function. Impl drop for atomic operation guard, fun drop mute self, mark end operation self.begin, sure. Finally, define the wrapper function which returns the guard value. Pub func mark atomic operation. Okay, we're not going to read all the code. By using the must use attribute, we can make the compiler give a warning if the result value is not used. This is important because that would mean that the atomic region gets closed as soon as it has been opened. With this basic building block, we can also support an alternative style where we pass a function to be executed with the temporary change in Golem's behavior. These are higher order functions, taking a function as a parameter and just using the already defined wrapper to apply the change. Okay, so it's basically like do this stuff atomically. That's cool based on what we understand about Golem. Let's see, transactions. I think this could be interesting, how they did transactions, but I think to be honest, I'm not that interested in the wrapper around how they did all this as much as the low level details of how they did it, which is probably proprietary to their actual system. So it's possible this isn't that interesting, but let's see. So they're talking about we need to use all of this. Let's just read some code and see if it goes into anything that is like surprising. Sure, there's a fallible transaction result. Yeah, to me, this is the docs for how you use this. Why did they write this as a blog post? I guess it's fine. I mean, this is probably useful if you really if you're using this for your main work. Maybe this is a nice way to take it. But I don't think this has a whole lot of super interesting points to me so far. We could just create closures capturing the input and output values and calling the traits compensate function and store these closures in a vec. Sure. Okay, we've got a little execute, we've got a fail, we've got a run. And again, this is still okay. Yeah, I think I'm done. Because this is pretty much just like, this is how you use our special functions that we created for you that do all this stuff that's low level. And I actually care more about the low level stuff. So this is, yeah, I care about the way this is actually done, not how you use their library. Okay, well, here we go. Let's just read the rest of this article. You guys caught that, right? Done. Boom. Golem. Yeah, it's an interesting idea. I don't hate it. It seems cool. I might try to use it someday for Rust code. Maybe it'll be a reason to just use WASM as a compile target just for the hell of it and see how it works. But for now, I don't know. I didn't find this so interesting. Yeah, it seems like a really good fit for Rust and WASM. I agree. I like that you don't have to write a Docker file. Like everybody, I was like, what's the easiest way to deploy something now, like on OCaml? And everybody's like, use fly.io. And I'm like, okay, how do I do that? And I look at their docs and it's like, write a Docker file. And I'm like, oh no. Of course, Nix will just write a Docker file for me, but I haven't figured that out yet. Anyway, I don't know if this will ever see the light of day, but if it did, hope you enjoyed it.